Good evening, all of you. My name is Sanjay Kumar Patel, Assistant Professor, Mechanical Engineering Department, MLV Textile and Engineering College, Bhilwara, Rajasthan. Here I will discuss on lecture drive friction clutches, types that depend on drive friction clutches. Here I have mentioned total 5 clutches related to drive friction. First one is cone clutch, second one is single plate clutch, third one is multi plate clutch, fourth one is semi centrifugal clutches, or last one is centrifugal clutch. Cone clutch. Here I have discussed about cone clutches, its working in schematic diagram. In this schematic diagram, first cone is female cone shown by green color. Second one is blue cone. This is the male cone. And second is shaft. Male cone is sliding on splines. That is the main cone that is slide on splines. Frictional material, that is the frictional lining material that can be deposited on male cone. Fourth one is spring that can push forward and backward to male cone. Clutch control, separated both cone by pressing, that is the clutch control. Rotating direction, both direction of the axis are possible, clockwise, anti-clockwise, both direction will be possible. Here schematic diagram are shown. Female cone, this is the male cone, this is the bearing, this is the splines. Clutch shaft, that is the clutch shaft, that is the spring that can be compressed to male cone in the direction of engagement. That is the surface area, that is called lining, that is made of the material just like rubber or leather. The engagement position, the friction surface are in complete contact. During the engagement, both male and female cone comes in completely contact position. This is done by mean of spring. That is done by mean of spring that be compressed towards the female cone, which kept the male cone pressed all time. When the clutch is engaged, the torque is transmitted from engine to flywheel and the male cone to spline gearbox shaft. For disengagement the clutch, the male cone is pulled out by mean of lever system operated through the clutch pedal, thereby separating the contact. Advantage. Here we have discussed advantages of cone clutch. The advantage of cone clutch is that the normal force acting on the contact surface in this case is larger than the axial force in bracket as compared to the single plate clutch, in which the normal force acting on the contact surface is equal to the axial force. That is the very important point. Here we have discussed on advantages of clutch. Disadvantage. This type of clutches is practically obsolete because of the following reason. First one, if angle of cone is made less than 20 degree, it will be difficult to disengage the clutch. It means permanently engaged male cone with female cone. A smaller amount of wear on the cone surfaces results in considerable amount of axial movement of male cone, for which it will be difficult to allow. It means that if wears comes on lining surfaces, it will be considerable that we can replace the lining with a new lining surfaces. cone clutches. Here in schematic diagram of the cone clutches we have shown, first one is the driving shaft. This is the driving shaft, this is the frictional lining, that is the applied force on male cone, that is the lining makes angle between horizontal and along the line of lining surface. Friction lining is equal to alpha. Alpha is equal to semi apex angle of the cone. The total frictional torque capital T is equal to mu W R. It means that T is equal to mu multiply W multiply R. Mu is the frictional coefficient, W is the applied pressure on male cone along the female cone. R is the mean radius. According to uniform pressure theory, mean radius is equal to 2 by 3 in bracket R1 cube minus R2 cube whole divided upon R1 square minus R2 square multiplied by cosec alpha. According to uniform wear theory, mean radius is equal to R1 plus R2 whole divided upon 2 multiplied by cosec alpha. R1 is outer radius, R2 is inner radius.